Today's presentation is on views in SQL Server. We'll do a little bit on kind of what they are, describe them, kind of their options, how to manipulate data through using views, what you can and can't do with that, how to index them and what that entails. And we'll do some memos. So what is a view? Views, depending on if you index it or not, it's kind of a virtual table. Well, it is a virtual table that you can reference in queries. You can, select star from the view or join to a view. You can use them as kind of an abstraction layer, so people writing queries don't write queries against an actual table. They just write queries against a view, and you can change the definition of the view pointing to one set of tables or another on the fly. They can have up to 1024 columns. That'd be a pretty wide view. And then you can add permissions around views like you can with tables. So just like tables drop, altering them, you can retain the permissions, whereas dropping and creating, you lose all the permissions you've defined. So with encryption, just like other objects in the database, you can't script them out. SP help text doesn't show anything. There are ways to get it, but they're kind of tricky. So yep, you can encrypt views. You can do schema binding with views, which means that it locks or creates dependencies to all the objects or all the base tables underneath it. So you can't drop them. You can't alter any base tables if a schema-bound view is dependent on it. If you try to do schema binding on a view and you have a nested view inside of it, that nested view has to be schema-bound as well. Okay, manipulating data. When you manipulate data, you can only do it against one base table at a time. Updating, you can only update data in one base table for records that are returned from the view. So if you just select star from the view and say you have some filtering built into the view, you can't update data in the base tables that would not be returned from that filtering query inside the view. Inserting data, you can't insert into a view where there's multiple base tables involved. So one recommendation was just do an instead of insert trigger on the view, which would grab the data, and then you could kind of do whatever you wanted with it. You could insert into 3 different tables if you wanted, but that seems overly complicated and kind of hidden. So deleting data from a view, it's also not allowed on a multi-base table view. Indexing views, it's only available on enterprise or developer editions of SQL Server. Once you index them, they turn into materialized views, so they're no longer just a definition of a query of base tables. It actually turns into a physical arrangement of data on disk. So that's kind of one thing to keep in mind if you start making lots of views and putting indexes on them, as you are taking up space on disk now. There's also there are other types of views, the standard views that aren't indexed and don't take up any space. Partition views have base tables in different databases. So there are a few rules around indexing views. This is kind of the most common ones. So when you create an index on a view, the first one you create is going to be clustered unique. Schema binding is required. It can only be base tables. It can't be views inside of what you're trying to index. There's no nesting. When you create the indexed view, it has to be in the same schema as all of the base tables. And when you do the definition, or when you're writing the query inside of the view, you have to do dbo.table name or your other schema.table name. You can't just the parser won't assume dbo is the default schema. And all the fields must be deterministic, so no get date values. They have to be set fields. So on to demos. So doing the camping store database again, inventory table, categories table, seasons, and then a sold per season, which has the season ID, integer, category ID, and a quantity sold. And we fill it. And then these are the seasons, just 4 seasons, 4 categories, and the items in them. So just can create this here. All right, so this is how you create a view. Let's just run this here, the query. We want to, this is the query that say we're going to use in lots of places, or you want to hand it to somebody, but they don't want to mess with this whole big query here. So we'll create a view. So we say create view, and we name it as, and then we have the query in it. We can say select star from our view here, and we get the same result as the query itself. We don't have schema binding on it. It's not encrypted. There's no indexes. So altering a view, you just say alter view as, and then you just have your new query. So we're going to add season ID and category ID to it. Say alter view, and we'll say select star from the view again. And now we have season ID and category ID in the view. So you can see it, we're querying it like a table now, even though it's not actually a table. It's just a set of instructions to go run this query, anytime you see this here. So we can have order ID. We can have an order by on here if we want to. Even IntelliSense picks it up too, so we can reorder the data as we want. Okay, nesting views. You can nest up to 32 views. That's pretty deep. I've seen a handful, but I can't imagine going 32 deep on that. Okay, so we'll create another view. This one, let's run the query here. So this one is, instead of just season overview, which is this data here, we're going to throw in the items description. So it'll be season overview detailed. Have season ID, the season name, category, the items, and we're going to split out how many items were sold in each season. So let's try to create this view, leaving the order by in there. And the server doesn't like that. They're like, well, we just want the query to give us a raw data dump, and then we can sort it on the outside. So let's say create view season overview detailed. So now we can say select star from that, which has a nested view inside of it, and we can get all that data back. We've got 2 views, a season overview and a season overview detailed. So let's add encryption to the view we just created, and you just have to add another line of alter view with encrypted. So let's see here. Now our view is encrypted. We can still select star from it and treat it as just regular view or table. So there's this help text. So we encrypted this one. When we try to use this to kind of see what's in our view, we get a message saying that it's encrypted and you can't view it. But we didn't encrypt our first view, so when we do help text with our first view, we get the definition here. You can use this on store procedures and other things to kind of see what's inside it. All right, on to schema binding. alter view and your view name, and then you just say with schema binding on it. So when you run that, we get an error message saying that we can't schema bind this detailed view because the nested view inside of it is not schema bound. So then we can schema bind the overview one. We'll schema bind that first one because it's only has base tables in it. There's no other views. And so now let's try to drop a table that was in that view, the schema bound view. Well, can't drop it because it's referenced by season overview. It doesn't say that it is a view, and it doesn't say that it's schema bound, but just dependent on it. We can try to drop a column in one of the base tables, and we get an error message again that it's dependent on this view. So updating data in a view. So this is a view. Let's try to update multiple tables. So this season column is from the seasons table, and this quantity sold is in a different table. We're going to try to update our view for these two records right here. I want it to say springtime. Can we do that? Oh, no, we can't because it affects multiple base tables. So if we just try to update one column, which would be in one base table, it lets us do that. And see now when we select star from our view again, the data was updated. So when you update one column or a set of columns that are in the same base table in a view, the server knows to go kind of trace backwards and update that base table. So inserting data into a view. Here's our table again. So let's try to insert data into each single column, even though it's split across three different tables. And you get the same error message. It's not updatable because it affects multiple base tables. Well, let's try to update into a single base table, the one that has the season ID, category ID, and quantity sold. That's one table, and we still can't insert. Because even though we were really just, the data coming back would be reflected here, it's still joined that the query in the view joins this table to this table to this table. So let's just create a quick little single table view on that sold per season table, which is where this one comes from. Create that view, and we can insert into that view because it's a single base table view. So now when we run our query again against that overview view, we see now that the record that we created in this one table is reflected because it's joining these three tables together. So on to deleting. So delete data. Let's try multi-table. Oh, we can't do that because it affects multiple base tables. This is that single table view we just created. Let's try to delete from there, and it lets us do it. So when there's multiple tables involved in a view, you can't insert into it, and you can't delete from it. You can update as long as you're only updating columns that are all contained to one of the base tables in the view. So now there's a with check option. So let's create another view, or I'll change one of the views. So we can the data returned from the view will only show records where the quantity sold is less than 10. You throw on a with check option at the end. So now let's try inserting into that view. Category 2, season 2, and with a value greater than 13. We get an error because it doesn't pass the with check option on there. We select from the view, the data is not there because we can't insert that. So with check option and filtering, the filtering stops data, or if it's running a query against a base table, it won't show the data that doesn't match it in the result set. But you also can't go the other way and put data into the view if it doesn't pass that filtering. All right, last section here on indexing views. You can use this SP spaced used and the object name. You can see here that the season overview view does not take up any data on disk. And like I mentioned, the first index you create on a view has to be a unique clustered. So we'll create a unique clustered index on season ID and category ID on the view, just like it was a table. And so now the index is created. And when we do the space used season overview now we see that it takes up 10 rows. It takes, 16K, 8K on disk. So there's only 10 rows in this table, but if you had a view on a multi-million row table, and then you throw an index on it, now you're taking up space on disk that you weren't before. That about covers it. Slides and scripts are online, and there's my contact email. Thanks for watching.